this video is going to look at solving a simple induction case. It's assuming that you have already looked at why we do the process of induction and how we do it and the reason that it exists. Okay, so we've got some non-negotiables of steps that we have to do, which includes we first must prove P1. Now, why is it P1? Because we're looking at here, we can say that that's positive integers, that's the notation. So we start with P1, that means your first term on the left-hand side, which we know is 1. On the right-hand side, we're going to replace anywhere we see n with 1, and we're going to show it. So we're going to need to say 1 times 2 times 1, take 1. You might think that looks like a bit of a pain, but please make sure you do it, because remember, you're basically given the answers here, so you need to show that it is true. Okay, so that does equal 1. In other words, that equals the left-hand side. And so therefore P of 1 is true. Again, this statement must be written. Okay, just tidy that up, that's annoying me. All right, then we go on. The next step that once we've shown that the first base is true, so in our case we've shown P of 1. Sometimes it could be P of 0. You've got to make sure that you read your question. So we write down, assume PK is true. So we go back wherever n is in our statement. We just replace that with K. All right, so we're happy with that. Now we're going to use PK to prove PK plus 1. So we must write the statement again. So what we want to prove is we want to prove that 1 plus 5 plus 9 plus, now this is, I think, a great tip. Make sure, so we write all up to this point is we have PK, and then we have our K plus first term. Right, so wherever K is, you now replace with K plus 1. So this becomes 4, K plus 1, take 3. That's your K plus first term. So this is your kth term. This is your K plus first term. Right, and that has to equal, again, wherever K is, we're replacing it with K plus 1. So 2 times K plus 1, so that's 2K plus 2, take 1, so it becomes 2K plus 1. All right. Actually, I will write the whole thing in there, and then I'll simplify on the next line. So K plus 1, take 1. So what we're doing here is we've got 1 plus 5 plus 9 plus all the way your K, write your K plus kth term again, and then I can simplify this one to be 4K. 4K times 4 is 4, take 1, take 3 becomes 1. Okay, and as we said before, we're just going to simplify the right hand side, so that becomes 2K plus 1. All right, now we start with our left-hand side. The reason that I asked you to write or include on the left-hand side the K plus first term and the kth term is that hopefully you can see that all of this bit here, that is equal to this, which means I can now replace that with PK. All right, so we've now got that all of that is actually replacing it with that bit there because it is K, PK. So 2, so left-hand side will be that. That's all of your terms up to the PK, and then you've got your K plus first term, which is the 4K plus 1. And what you're trying to do is make that left-hand side equal to this. Okay? So here we go. Let's have a look. And by the way, once we do this, you must put in here using, so once you've substituted for PK, please make sure that you pop in there PK. So everything up until this point is just process, rewriting, substitution. The algebra only kicks in now. All right. The only thing that we can do, so I would say look for a common factor. there isn't one. So the best thing to do is to expand and then see if you can make it look like the right-hand side. So I've got 2k squared minus k plus 4k plus 1. We've got 2k squared. That becomes 3k plus 1. And now we wish to factorize this, and we can see pretty easily that it does indeed factorize nicely, because the only factors of 1 are 1. And that equals our right-hand side. Okay, so everything, I would say, up until this point is pretty much set in stone. It's just rewriting, substituting. It's at this point that then you have to try and look at some algebra. All right, so we're done. Don't lose your last mark in these questions, because then you must put, okay, your statement. And this basically summarizes everything that you've done. So what did you start with? We started with, so since P of 1 is true, that's what we proved at the beginning, and P of k plus 1 was true only when, right? When P1 was true, PK was true, sorry. So since P1 is true and PK plus 1, miss that, is true, whenever when PK is true, all right, then Pn is true for the values that you proved it for, which were positive values n, and how we proved it by mathematical induction. Okay, make sure you include your statement. That's that one done.